Hello everybody, welcome to Pencil College. In the previous video, we have learned about the rate of change. Okay, so today in chapter 15.2, we will learn about the connected rate of change. So basically, finding the rate of change of something, and then the other thing could be another change variable which can change. So how are we going to find it? So for what do I mean by that? So for example, let's say I have y is a function of x, then x is also a function of t. So we would expect that when y changes, then t would also change. But how do I find dy dt then? Okay, so we will do that in a moment's time. Okay, so before we can start, I need you to recall chain rule. Remember, we have once said chain rule could be written in this form. Okay, so dy over dt is equals to dy over dx times dx over dt. Okay, so we will also make use of chain rule to solve connected rate of change problems. Okay, so hence the title of this topic. Okay, so let's try an example. So for example, a drop of ink drips onto a filter paper and the radius of circle form expands at a rate of 3 millimeters per second. So find the rate of increase in area. Okay, so let me give you a background information. So for example, the radius is changing. So the dr dt is actually 3. Okay, by right I have to write millimeters per second, but let's just assume that it's purely mathematical problem, and I'll just write 3. Okay, so dr dt is 3. What I want to find is actually dA dt. Okay, so this is what I want to find. Okay, but however, I know that A is also equals to pi r square, right? Okay, so in actual sense, I can actually find dA dr. Okay, so dA dr, we know by differentiating this thing, we get 2 pi r. Okay, and then recall chain rule. Okay, chain rule says that dA dt is just equals to dA dr times dr dt. Okay, so this is chain rule. Okay, so very simply we just have to sub in the numbers. dA dr is just let me see, dA dr is just 2 pi r, and then dr dt is just 3. Okay, so the rate of change of area with respect to time is 6 pi r. Okay, so that's our answer. Okay, so in certain cases the question will also say find the rate of increase in area at when it is at a certain radius, for example 3. So all you have to do is to sub in 3 into this r. Alright, so basically for connected rate of change problems, we usually just have to find the chain rule equation. So the most important thing is to find the chain rule equation. Okay, for connected rate of change problems. And then after that, we find what we need. Find all the elements or the rate of changes, the different rate of changes of the chain rule equation. So of the chain rule equation. And then after that, we just have to substitute the necessary conditions. Okay, so chain rule problems are rather easy to solve. Connected rate of change problems. Okay. Okay. In summary, we have the chain rule, which is the key to our topic over here. So you need to remember the chain rule. The chain rule states that dy dt is actually equals to dy over dx times dx over dt. So it's like as if it's a fraction I can cancel, but never show that you cancel this thing because it is actually not a fraction. Okay, it is a symbol. Okay. So we also learn how to use chain rule to solve connected rate of change problems. Okay, so basically if things are related by a certain equation, you can always differentiate the equation and find the rate. And if you know the rate of change of one unknown, you can then use it to find the rate of change of the other unknown. Okay, so let's just recall what we have done. So for example, we have a relationship y is equals to fx. So we know y in terms of x, we can find y prime. Okay, so y prime is just differentiating f of x to get f prime of x. Okay, so then okay, this will also equals to dy dx, right? So if I have dy dt, if I want to find dy dt and I have and I have dy dx from here, and I also have dx dt, then I can find them. Sorry, this is not a plus, this is a multiplication sign. Let me get back to it. Okay, so similarly, if I have dy dt only and dy dx, I can use it to find dx dt. Okay, so very is a very simple equation actually. Okay, here are some questions in the Penpack A Maths textbook that you can practice. Try with the first two problems first, they are rather easy, and then move on to the level 2 questions. With that, I thank you for watching this video. For more videos, please visit pencilcollege.com. See you in the next video.